swings of the stock market? It's a question worth trillions. And in this explainer, we're going to try to find an answer. It kind of sounds like science fiction, doesn't it? The idea that some algorithm can just see the future of stock prices. I mean, tons of people have tried, and believe me, many have failed in some pretty spectacular ways. But we're going to follow a data-driven path to see if it's actually possible. And we're not just going to talk about it in theory. Nope. We are going on a builder's journey. We're going to follow an expert's project, step by step, as they build a predictive model right from scratch using real historical data. Okay, so here's the game plan. We'll kick things off with that big question, then we'll get our hands dirty with 3 key steps: getting the right data, building our first simple model, and then leveling up to a much smarter one. And trust me, you are going to want to stick around for the end. The final result is genuinely not what you might expect. All right, our quest begins. And again, this isn't just a thought experiment. We are following a real-world project with actual code and data that tries to crack this very problem. So the proving ground for our experiment is the S&P 500 index, the big one, the benchmark for the whole U.S. stock market. We're digging into decades of its price history, going all the way back to 1950, to see if an algorithm can learn from the past to give us a clue about the future. And that brings us to step 1. Look, any machine learning project lives and dies by its data. It's everything. And when you're dealing with something as messy as the stock market, how you frame the problem is absolutely critical. So right off the bat, the model builder makes this really, really smart choice. They're not trying to predict the exact price of the S&P 500 tomorrow. I mean, think about it. You could predict the price will be, say, 4,500, and it ends up being 4,501. Technically, you were incredibly accurate, but if you bet the market would go down, you still lost money. So instead, the model is built to predict something way more useful. Will the price go up or will it go down? So here are the nuts and bolts of how that's done. First, you download all that historical data. Second, you clean it up. Get rid of columns like dividends or stock splits that don't really matter for an index. And third, this is the most important part, you create a brand new column called target. If tomorrow's closing price was higher than today's, you put a 1. If it was lower, you put a 0. That's it, a simple, clean signal for our model to go after. All right, our data is prepped and ready to go. Now it's time to train our first very simple model. This is our baseline, our first shot to see if there's any kind of predictable pattern hiding in all this data. The tool being used is called a random forest classifier. It sounds super technical, I know, but the idea behind it is actually pretty simple. Instead of just relying on one decision-making model, a random forest builds hundreds of them and then basically has them vote. It's like asking a whole room full of specialists for their opinion instead of just one person. It's a powerful way to spot complex patterns. But hold on. Before we get to the results, there is a massive, flashing red warning sign here, a trap that almost everyone falls into when they start. As the project's creator put it, if you're not super careful with data that's based on time, you can accidentally leak information from the future into your model's training. It's like giving it the answer key before the test. Your results will look amazing, but they'll be totally, completely fake. So, after carefully avoiding that data leakage trap and training our first model, what was the result? Well, the model scored a precision of 42.8%. So what that means is, of all the times our model confidently predicted the market would go up, it was only right less than 43% of the time. To put that number into perspective, a simple coin flip would get you to 50%. Our intelligent model performed way worse than just random chance. You would have literally made more money by doing the exact opposite of what it told you to do. Ouch. Not a great start. But hey, this is where the real work begins, right? Failure is just data. And that terrible first result, well, it just tells us that we need a much smarter approach, both in how we test the model and in what kind of information we feed it. So the key to a more realistic test is a technique called backtesting. This is how the pros do it. Instead of one simple data split, backtesting is a tough, rigorous simulation of how your model would have actually performed year by year, making absolutely sure it never gets a peek at the future. Here's how it works. First, you train the model on, say, the first 10 years of data. Then, you use it to predict year 11. After that, you retrain the model on the first 11 years of data to predict year 12. You see the pattern? You keep inching forward through time, making sure your model only ever knows what it would have known at that exact point in history. So after we apply this much better backtesting method, what happens? Well, our simple model's precision jumps up to 53.3%. That's a huge improvement. But here's the kicker. If you look at history, the S&P 500 just naturally goes up on about 53.6% of trading days anyway. So our model still isn't giving us a real edge. It's basically just discovered that, hey, the market tends to go up. This tells us the model needs better information, better food for thought. So it's time to stop feeding it raw price data and give it some smarter features, the kind of stuff a human analyst might actually look at. We're going to give it ratios, comparing today's price to recent averages. And we'll give it trends, like how many up days there have been over the last few months or even years. We're giving it context. And there's one last really clever tweak. We're going to raise the bar for what counts as a prediction. We basically tell the model, look, I don't want to hear from you unless you are at least 60% sure the market's going up. The goal here is to get fewer predictions, but to make sure the ones we do get are much, much higher quality. All right, this is the moment of truth. After all that work, a better testing method, smarter data features, a higher confidence bar, what's the final result? Did all of this effort actually pay off? And here it is, the entire journey in one simple chart. We started in the gutter with a disastrous 42.8%. We found that the market's natural baseline, just random chance, is about 53.6%. And our final, smarter model, it hits a precision of 57.1%. After all that, we actually found a consistent, verifiable edge. Now hold on, a 57% success rate is not a magic crystal ball. That's the reality here. The goal isn't to be right 100% of the time. It's about finding these small, repeatable, and statistically meaningful advantages that you can use over the long run. And it looks like this model has actually found one. And of course, the journey doesn't stop here. The project's creator lays out some really clear next steps to make the model even better. I mean, you could start feeding it news sentiment, add economic data like inflation or interest rates, look at how global markets are moving. The quest for a better model is really never over. Which leaves us with a final, fascinating question to chew on. On the surface, a 4% edge over the baseline seems pretty small, but in the world of high-stakes finance, where billions of dollars are moving every single day, is that small, consistent edge the secret to building a fortune? Or is it just enough knowledge to be really, truly dangerous? Something to think about.